A problem but in a more de anya self. Alright, hi everyone. So here was where we ended the class in the previous section. That was question number 7. Okay, so we would like to continue from here and to see how far we can actually go. Okay, so the number 7 is from, number 8, because we completed number 7. Okay, question number 8 is from indices. So, and it's asking us to evaluate 8 to the power of 1 over 3 multiplied by 8 to the power of 2 over 3 all over 10 to the power of 2 over 3. Okay, so permit me to raise this maybe. Okay, I don't know. Let me see if I will see where it was. Okay, see it here. Okay. Okay, so we have 8 to the power of 1 over 3 to be divided by, to be multiplied by this. So what do you do? By law of indices, you recall that a to the power of n multiplied by a to the power of m is the same thing as a to the power of n plus m. So we apply that here. That will get us 8 to the power of 1 over 3 plus 2 over 3. Okay, that really makes this question very simple, but let me be sure that that's okay. Sorry, I wondered that this really made the question very simple. So this is not 8, the second one is 5, right? So what are we expected to do here? Now we will try to reduce this to its lowest base possible. We can actually write 8 to the power of 2, and so that will be 2 to the power of 3, and then you know the rule that says that if there is a power and then raised to another power, that two of them, the two powers will now multiply. So let me put it that way. So this power will now multiply 1 over 3. Ensure to write that as multiplication, or to know that what you have there is multiplication of powers. Okay, so this is multiplied by 1 over 3, then times 2 raised to the power of 2 over 3, 5 to the power of 2 over 3, you leave it that way. Now observe what I'm going to do in the denominator. You will see that my numerator has a base of 2 and 5. My denominator cannot be reduced to a base just like I did with 8, but I can change it to a product of 2 and 5. So 10 is the same thing as 2 times 5, and everything is raised to the power of 2 over 3. Now you are going to see what that breakdown is going to do for us, because we are told that if I have a times b all raised to the power of n, that it is equal to a to the power of n times b to the power of n. So power distributes over multiplication. So that's going to be, this will be, of course, this one will cancel this to now give me 1 here. So I just have power 1. Okay, yeah, so I just have power 1 here multiplied by 5 to the power of 2 over 3, and that is all over. So if this thing happens like this, so I will get 2 to the power of 2 over 3, then multiplied by 5 to the power of 2 over 3, and immediately something will happen. This one will cancel this because they are equal. Okay, so and that is going to now give me 2 to the power of 1 all over 2 to the power of 2 over 3. which you can now apply the other rule that says that a to the power of n all over a to the power of m is equal to a to the power of n minus m. So this is going to give us 1 minus 2 over 3, which is equal to 2 to the power of 1 minus 2 over 3 is the same thing as 1 over 3. And that is the solution to this problem, and it's a very good place to stop. Okay, so it's a good place to stop. All right, so and that is the solution for number 8. So we go over to number 9. All right, so number 9 is another indices question, and we are also asked to simplify 6 to the power of 2n plus 1 multiplied by 9 to the power of n, then multiplied by 4 to the power of 2n, okay, everything all over 18 to the power of n multiplied by 2 to the power of n. Remember that this thing is 9, and then multiply by 12 to the power of n. And just like I would say in all other exercises we do in other courses, all my exercises are usually unscripted, meaning I didn't have time to solve them before bringing them to you on these live sections. And the reason is so that we can walk through these solutions together, so that we'll be trying to interpret them by ourselves. Okay, so together like that. All right, so what do you do here? Let's look at it together. So I cannot write 6 to any smaller base, but I can split it into 2 times 3, just like I did 5 times 2 here. And but I can write this other 2 in smaller bases. So let's do that. So I'll write this as 2 times 3 raised to the power of 2n plus 1, then multiply by, you can use dots to do multiplication or to signify multiplication. So this one can be written as 3 to the power of 2. That 2 will multiply the already existing power, which is n. That's then multiplied by 2 to the power of 2. That 2 will multiply the existing power, which is 2n. And that would have given us 4n, but let me still just put it that way. So all over, then the denominator, the same thing is going to happen here. I have, okay, and I just saw something now which would have been of use to us. And what is it? My numerator now, which is 9 to the power of n, I didn't need to bring it down. I can still leave it that way, and I'm going to show you why. Remember I told you we are doing this together here, so you are going to see why. Because inside 18 I am going to get 2 to the power of 2 times 9 to the power of n. So by the time I open here, you will see 9 to the power of n, so I can easily cancel the 2. So no need doing that expansion. So you now have 2 to the power of n, then multiply by, here I can have, you will see another one. This is the same thing as 3 times 4 to the power of 2n. So that means again I didn't need to also expand this one, so I should have left it as 4 to the power of 2n. And then by the time I expand this, you will see that the two of them will cancel out, so there was no need in the first place. Okay, so I'm aware that you are seeing some beautiful things. Okay, so which I keep saying that this is why people must get involved in solving problems, because it is in doing that that you are able to see where you can how the approach you can take without wasting time. So open this bracket now. You will get 2 to the power of 2n plus 1 multiplied by 3 to the power of 2n plus 1. Then I have 9 to the power of n, and then I have 4 to the power of 2n. divide this, okay, open this bracket, you get 2 to the power of n, multiply by 9 to the power of n, multiply by 2 to the power of n. Then if you open this other bracket, you will get 3 to the power of 2n, then multiply by 4 to the power of 2n. Okay, alright, sorry about that. So what happens now is that I will now look for ways to cancel out common values. So this will take away this, 9 to the power of n will take away 9 to the power of n. Okay, so and then you can clearly see that we can join 2 to the power of n with 2 to the power of n in the denominator, but I'm going to retain this one like this. However, in the numerator I will need to split them. You know, you can write a to power n plus m in the opposite direction, and that will give you power n times a to power m. So I'm going to be splitting the numerator now. So you have 2 power 2n times 2 power 1 multiplied by 3 power 2n multiplied by 3 power 1. So following that rule, okay, and everything is all over. Now if you join this and this, you are going to get 2 to the power of n plus n, which is 2n, then multiplied by this one, bring it down the way it is, that's 3 to the power of 2n, and you are done. So immediately you would see this will cancel out this one will cancel out this one, and so you just have 2 times 3 left, and your solution to that problem is equal to 6. Okay, so it gives you 6, and that's so beautiful, very, very beautiful. Okay, all right, so you have 6. All right, so remember that there are other approaches you can take. So assuming I allowed that 2 to the power of 3 to the power of 2n here, and here it's also the same value, you just open up your brackets and you get the same thing. So but that would have maybe taken you longer steps. All right, so and that's for number 9. We go to number 10. Okay, so number 10 says if 9 raised to the power of 2x minus 1 divided by 27 to the power of x plus 1 is equal to 1, we should find the value of x. So what value of x will allow this to be true? Okay, so let's try to solve. Solution. So what do we do first? We will try to first of all simplify what we have here. I can write 9 to power 2x as 3 to the power of 2. That 2 will multiply the existing power, which is 2x minus 1. And that's all over 3 to the power of 3 also. So 2 of them can be written in the same base. And then this one will multiply the existing power, and this is equal to 1. Okay, so it makes my job very easy. So what will happen? You will just apply the division rule, which I already mentioned up there. So what will give us, this is going to give us only 3. We pick only base 3, and then this minus the power below. So if we open this, we are going to get 4x minus 2. Then we are doing minus the denominator. The denominator is going to be 3x. Then 3 times 1 will be plus 3. Okay, so you're subtracting this power below, and that's equal to your left hand side, which is 1. Then I'm going to go straight to make that 1 3 to the power of what? 0. And you know why I chose to do that? Because I needed to equate the powers, because once the bases are the same, you can take them out of the equation and then equate your power. So I have 4 minus x. If I open here, I'll get minus 3x minus 3 is equal to 0. So what that does for me, I will then simplify. 4x minus 3x is x. Then minus 2 minus 3 is minus 5. Take it over to the other side. That will give your x as equal to 5. Alright, and that is the solution for number 10. Okay, so we move over to number 11. Okay, so that number 10 exercise happens to be the last question on indices for now. So we move over to the next, which is now logarithm. So look at 11. It says we should simplify 3 log 9 base 6 plus log 12 base 6 plus log 64 base 6, then minus log 72 base 6. Okay, so what do we do with that? So we will try to, of course, use the laws of logarithm, but the laws that says that if the bases are the same, that addition should change to multiplication, while subtraction should change to division. However, if there is a coefficient, you need to clear it first. So I'm going to clear that coefficient. And how? There is a law that says that if I have n log a to whatever base that is the same thing as log a, this n will come up here to become a power. So this is going to be 9 to the power of 3. Then base 6, every other thing will follow. Alright, because they are already in order. So I'll have 64 base 6 minus log 72 base 6. Okay, so at this point I will now apply that rule of logarithm that says that I can actually pick one of the log base 6, and then addition will turn to multiplication while subtraction will turn to division. So this is going to give me 9 to the power of 3. And what is 9 to the power 3? That's 81 times 9. Okay, maybe we should still keep it that way. 9 to the power of 3 multiplied by 12 multiplied by 64, and then that is all over 72. Okay, so what does this give to us? So it gives us so we are going to have the log base 6. So if we try to simplify the value we have there, which is 9 to the power of 3, let me do that. Okay, multiplied again. Okay, 9 to the power of 3. Of course, 9 can divide 72. In fact, let's do that. 9 here is 9 to the power of 2, which is 81. And then 9 here will give us, let's see, 9 into 72 will give us 8. Okay, and 8 here is 1, 8 here is 8. Okay, so we just have 81 multiplied by 12 multiplied by 8, sorry. Okay, so that's giving us log 7776. Okay, so whenever we have a log to a particular base and we want to simplify, one thing we should try to see is it possible to write this number in base 6. Okay, so that way we'll be able to simplify. So we will try. So we'll try to see how do you do that. Start dividing by 6. So I've divided by 6 one time. I divide again. That's 2, 3, 4, and then 5. So I divided 5 times to get 1. Okay, so that means my 776 is the same thing as 6 to the power of 5, and that's base 6. Okay, so now I need to do the same thing I did here. I'm going to do it in the opposite direction. So I'm going to take this 5 to the back now, and that's going to give me 5 log 6 base 6. So why did I do that? Because there's a rule that says that log of a number to the same base is equal to 1. Alright, and so this is going to give me 5 times 1, which is equal to what? 5. Alright, and so your answer for number 11 is 5. So we move over to number 12. So for number 12, it's also logarithm. We are given if log 2 base 10 is equal to 0.3010 and log 3 base 10 is equal to 0.4771. So we are to evaluate the log of 4.5 base 10. Okay, so what do you do with that? That's very straightforward. All you need to do is, whenever there is a fraction, a decimal, always try to first of all change it to fraction and see what it will give. So this will be 9 over 2 base 10. And so you are going to have that this is equal to, now by division, remember we said up there that division is the same thing as subtraction of log. So this is going to be 9 base 10 minus log 2 base 10. Okay, and then remember that in all of this we will try to see how we can express this log to now contain only log 2 and log 3, because these are the logs that we have their values, and we have achieved that here. Excuse me. So we have achieved that here, so we need to also see what we can do with this one. And of course this is the same thing as log 3 to the power of 2 base 10 minus log 2 base 10. So I can bring the 2 to the back, and that will give me log 2. I'll have 2 log 2. So I'll have 2 log 3 base 10 minus log 2 base 10. So at this point I can now try to substitute. So what is the value for my log 3? I'm not sure this thing will enter there. So let's move it to this way. In fact, that's what I should have done earlier on. Okay, permit me to do this. Okay, alright, so I'll be able to use that other part. Okay, so this is going to be equal to 2 times, what is log 3? They said is 0.4771. So this will multiply that. Then minus log 2 base 3 base 10, they said is 0.310. Okay, so all you do now is multiply this and then subtract. So 2 times 0.4771, okay, minus that is giving us 0.6532 as the solution to the problem there. Okay, and that is okay, so that is number 11. Okay, sorry, 12. Number 12. Okay, so we have the value for number 12. So what does that do for us? Okay, so we go over to number 13. All right, so number 13 says solve for m. Let me write it. Solve for m in the equation. Solve for m in the equation. Okay, and the equation is given as log of 1/16 raised to the power of 2m plus 2, and the base here is 2, is equal to log of 8 to the power of 5m plus 1 all over 3, and that is in base 2. Okay, excuse me. Okay, sorry for that distraction. So you're welcome back. So what do you have here is that solution. What are we going to do? So you can see something, and what is that? That all the numbers of the logarithm are in index form, and their bases can be written in base 2, since the base of our log is base 2. Whenever this kind of log is given, your interest is to see how the number here will be equal to the base, so that everything will go to 1. Okay, so what do? I can write that as log 1 over 16 is the same thing as 1, follow me, is the same thing as 1 over 2 to the power of 4. I want to do that thing at once. So, and 2 to the power 1 over 2 to the power of 4 by indices, I can write this as 2 raised to the power of minus 4, because we are told that 1 all over a to the power of n is the same thing as 1 all over a to the power of minus n. Okay, so I'm going to apply that here. So that's going to give me 4 to the power of 2 to the power of minus 4, and that power will now multiply the existing power there, which is 2m plus 2. Remember, this is to the base of 2, so I can remove this. And then on the right hand side, I will do the same thing. I will have the log of 2 to the power of 8, and that is multiplying 5m plus 1 all over 3, all in base 2. Okay, so the beautiful thing you will see here is that this 3 here will cancel this 3. So now I can take all the powers to the back. So this power will come to the back, and it's going to give me now minus 4 into the bracket of 2m plus 2. Now this will now be log 2 base 2 equal to, while on this side I'm just going to have only 5m plus 1. So, and then times, that will multiply log 2 base 2. Okay, so that should not be where that bracket should be. That bracket should be here. So showing that the whole of this is multiplying this. Alright, so meanwhile this will turn to 1 and this one will turn to 1. So you just have, of course, open this bracket, minus 8m minus 8 is equal to 5m plus 1. Okay, so I'm going to collect like terms since, okay, anywhere. So if I bring m to this side, I'm going to have minus 8m minus 5m is equal to 1. This one coming here will be plus 8. So if I subtract this, I'm going to have minus 13m is equal to 9. And therefore my m alone is 9 all over minus 13, which I can write as minus 9 all over 13. Okay. Okay, so sorry, this is 2m plus 3, not plus 2. Okay, oh my god, this is plus 3. So let's just correct it. Okay, the places we made that mistake. So plus 3, and so here is 3, and so here is 3. So let's come down. It will affect our answer. Of course I can change here, and then it will affect this one, and then this one, and the final answer. So let me quickly correct that. So if you open this bracket, you should get minus 12, and then by the time you transfer this side, it will become plus, which will give you plus 13. So this should be 13 all over minus 13, which is equal to minus 1. Sorry about that. Okay, so we go over to the next one, which is number 14. In number 14, we are asked to find x if the log of x base 9 is equal to 1.5. Okay, so all we need to do here is to use the definition of logarithm. And what's the definition I'm referring to? We are told that if I have the log of a to base x to be equal to n, that it actually means that x to the power of n is equal to a. That means the base raised to the power of the value is equal to the number of any logarithm. Alright, and so if we apply that here, it means that 9 to the power of 1.5 is equal to x. Okay, so all we need to do now is to simplify that, and that's going to give us our x is equal to 9 to the power of, change the decimal to fraction, 3 over 2, which is the same thing as remember that denominator, when you have fractional index, denominator will turn to roots, and then the numerator will remain as power. So so that's going to give us square root of 9 is 3 raised to the power of 3, and that is equal to 27. Okay, so our number 14 is equal to 27. Okay, so so now we can continue since we have a little more time. So we go to 15. Let's see, maybe we can reach up to number, let's see if we can get to 20. 20 is series and sequence. So from 15 now to to 19 is talking about surds. Okay, so let's see, maybe we can get to 19, and then in another section we'll now look at 20, which is under series and sequence down, and then it continued, series and sequence continued down till number 30. Okay, so we'll see what we can do when we get there. Okay, so let's go to number 15. So number 15 says we should simplify the expression 5 root 32 minus 2 root 18. So what do you do in simplification of this kind of surd or radical expression? Okay, so is to try to see how we can, of course, before you add or subtract surds, they must be similar. So we'll try to see how we can make this to become similar. Alright, and that is going to give us, this can be written as 16 times 2. Why this one can be written as 9 times 2. Okay, so which is going to give us, you bring out this 16 by taking its square root, and that will give us 4. So that 4 will come out, and when it does, it will multiply 5. So we'll have 20 root 2 minus, the same thing will happen here. The square root of 9 is 3. 3 times 2 is 6. So we have 6 root 2. So this is now similar. Meanwhile, similar surds is just when you have two or more surds that have the same irrational part. Okay, so 20 minus 6 is going to be 14 root 2. And that is the value for number 15. Okay, so let me do 16 somewhere here, right? So 16 says that we are given that root 2 is equal to 1.414 approximately, of course. So it says without using tables or calculator, find the value of 1 all over root 2. Okay, so first of all, of course, you may choose to just substitute immediately and then divide 1 by this 1.414. But that may be a little more difficult than what you will have if you try to rationalize this surd. That's remove the radical from the fraction, and so, or from the denominator. So what do? I'll try to rationalize, which is going to give me, just multiply the numerator and denominator by root 2, so which is going to be equal to root 2 all over root 2 times root 2 is equal to root 4, which is 2. And so at this point, I can now substitute. My root 2 is 1.414 all over 2. So it's actually easier to divide divide without calculator what we have up here than dividing 1 by that decimal number. So that one will be tougher. Okay. So in doing this, we can actually use short division. Okay. So 2 divide 1, it can't go. You have 0 point, then carry over that 1 to here. That's 14. 2 into 14 is 7. 2 into 1, it cannot go. You write 0, carry that 1 to 7, and that will, to 4, and that will give you 14. And 2 into 14 is 7. And so your answer is 0.707. So we have done that evaluation without a calculator or a table. So number 17. Okay, number 17 says we should find the value of k. Find k if k all over root 3 plus root 2 is equal to k root 3 minus 2. Alright? So we need to find k in this particular question. So what do you do there? Okay, so to find k, what we are going to have, sorry, excuse me, my pen. Okay, so what we are going to have solution is that we try to simplify the left hand side to be in the form, to be like this right hand side. And how do you achieve that? You will achieve that by rationalizing. So if I rationalize, just like what we did in 16, to rationalize is to multiply both numerator and denominator by the conjugate of the denominator. And the conjugate of denominator is just to change this sign to minus. Okay, so and that's going to be root 3 minus root 2. And then on the right hand side, you bring down this the way it is. So that's going to give us, so let's now start the multiplication. K, of course, you can put this in brackets so that you will know what that is going to give you. So which is going to be equal to K times this will give us K root 3 minus K root 2. Okay, and that's all over. Now, how do you do the multiplication of the denominator? This is just the same thing as difference of two squares. So root 3 will multiply root 3 to give us 3, minus root 2 will multiply root 2 to give us 2. This is actually how you multiply conjugates, okay, without wasting your time. So this will be equal to K root 3 minus 2, okay? Alright, so here now you just have 3 minus 2 is 1. So you just have K root 3 minus K root 2. And that's equal to K root 3 minus 2. Okay, so how do you then get the value for your K here? So you can easily see that okay, let's consider this appropriately and see what is possible, because what I can see here is something that is not incomplete, because this part should also have a root. But is there anything we can do to see that we get our solution? Yes, there is something we can do. And what is that thing? We can just okay, bring this other K to this side, and if you do that, you will have K root 3 minus K. Okay, even without bringing it to that side, we can easily eliminate the two of them, because they are of the same sign and they are on opposite sides of an equation. So you just have minus K root 2 equal to minus 2. Okay, let the minus cancel. Alright, so this will give you K root 2 is equal to 2. Therefore, our K alone will be equal to, divide both sides by root 2, you will get 2 all over root 2. And that is our solution. So you see, my eye was on comparing both sides, and I didn't see that these two could actually cancel out. So that's what exercises does for you, or what they do for you. So you are able to see the best approach to take and not waste your time. Okay. All right. So from there we move over to number 18. So number 18. What's the question? It says that you are given that we are given that P is equal to 1 plus root 2 and Q is equal to 1 minus root 2. Okay, so they are asking us to evaluate P squared minus Q squared all over 2PQ. All right. Okay, so what do you do here? There are two ways you can go. Either substitute your P here and then expand the square, and the same thing for Q, or you can simply apply difference of two squares. And I think I prefer that. Difference of two squares says that P squared minus Q squared will simply be equal to P plus Q multiplied by P minus Q, okay? All over 2PQ. Alright, and then we will try to substitute immediately. What is our P? 1 plus root 2. And what is our Q? 1 minus root 2. Good. Then open another bracket. our p 1 plus root 2 minus our q. You know, when you have minus and you have two terms, you need to put it in another bracket. So here will be 1 minus root 2. Okay, close the bigger bracket. This is all over 2 times our p is 1 plus root 2, and our q is 1 minus root 2. All right, so see what that is going to give to us. Very beautiful something. All right, so up here we can cancel out. This will take away this, and then we are going to have only 2 there into the bracket of 1 plus root 2. Then if you open this bracket, you have minus 1 plus root 2 all over. Now in your denominator, see what will happen. This is difference of two squares in expanded form, so we want to shrink it. So that means 1 squared minus the square of root 2. Okay, and that's going to give you 1 squared is 1, then the square of this will be 2. Okay, you still close it in a bracket, and that's going to be equal to, so here now it is 1 that will cancel out, so you just have, okay, and you can immediately see that your 2 here cancels this 2 here. Okay, so and that's going to give us only root 2 plus root 2, which is 2 root 2, and that's all over 1 minus 2 is minus 1, and that is all. Your solution is minus 2 root 2 as your answer. Okay, so we have minus 2 root 2 as the solution for number 18. Okay, and then we go over to number 19, which happens to be the last on surds. So there we have that if 2 root 3 minus root 2 all over root 3 plus 2 root 2 is equal to m plus n root 6. So we are told to find m and n. Okay, is that possible? Yes is the answer. Yeah, because every problem has a solution. You must always have that mindset that every problem has a solution. And the beautiful thing is that before we even give you a problem, we have already gotten the solution. So yours is to find that solution that we found already. Excuse me. Okay, so what you're going to have now is the same thing we did up there. Here you are going to try to transform this side to look like this. So you are going to take the rationalization of the surds. So in doing that, we will have 2 root 3 minus root 2 all over root 3 plus 2 root 2. So here we are multiplying both numerator and denominator by the conjugate of the denominator, which is root 3 minus 2 root 2. So you are just changing this to minus all over root 3 minus 2 root 2. Okay, and so when you now open up the both brackets, you are going to have 2 root 3 times root 3. That's going to give us 2 root 9, and root 9 is 3. Then 2 root 3 times 2 minus 2 root 2 is going to be minus 4 root 6. Okay, I hope that is clear. Then we go over to this. Minus root 2 times this will be minus root 6. And minus root 2 times this is going to be plus 2. Then root 4. And root 4 is equal to 2. So I'll remove it and put 2. All over our conjugate, remember how I told you to do that? This should multiply this, then minus, then this one will multiply this. That's all. So root 3 times root 3 is root 9, which is 3. And then 2 root 2 times 2 root 2 will give us 4 root 4, which is 2. Okay? And so you now have, let's simplify what we have. 2 times 3 is 6, plus 2 times 2, which is 4. So if you add the 2, you get 10. Minus 4 minus 1. You know the coefficient here is 1. That's going to give us minus 5 root 6. All over. Here will be 3 minus 8, which is minus 5. Alright? And you are done. All you need to do now is you can factorize 5 from the numerator. Why am I doing that? Because I want to cancel this denominator. Or in fact, factorize minus 5 so that everything in the denominator will go. So if I factorize minus 5, see what will happen. Minus 5 divide 10 will give me minus 2. Minus 5 divide this one will give me plus root 6. And that is all over minus 5. So you see my minus 5 will cancel minus 5. And so I just have minus 2 plus root 6. So I've been able to simplify the left hand side. And so I can now equate it. So this implies that minus 2 plus root 6 is equal to m, which is on the right hand side, plus n root 6. So you are just going to compare both sides now. So you are just going to compare both sides now, and it is clear that your m is the part that does not have any root, while your n is the coefficient of root 6 here. Therefore, my m is equal to minus 2, and my n is equal to the coefficient of root 6 here is 1. And this is my solution. Alright, so and that is the solution for number 19. And like I said, it would be nice that we end this one here, so that in the next section we are going to start from number 20, which is clearly on series and sequence. That's AP and GP and all of that. And then when we get to 30, which is the end of series and sequence, we'll now enter into number 31. Says find the sum of all numbers between this and this which are divisible by 4. Okay, that's also series and sequence. So we end at number 31 for series and sequence, and then from 32 we get into probability. All right, and then we drive it that way, and then that will help us finish, so that we are able to align our thoughts in each section. All right, so permit me to end this class here, and then we'll continue in the next section. Bye.